Hey Algebra 2, here are your notes for 10.1. We're going to be talking about midpoint and distance formulas. So for number lines, we can use absolute value and averages in order to find distances and locate midpoints. Well, we can do the same thing in the coordinate plane, except in order to find distances, we need to use the Pythagorean theorem. So let's jump right into it. I have all the formulas you're going to need at the top of the page. I'm not going to go over them other than to just point out that this side is the number line. So you're going to notice you've got a coordinate A, a coordinate B as you would on a number line, whereas in the coordinate plane, you're going to have x, y coordinates. And then same thing, distance formula, you only have an A and B point, whereas with coordinate plane, you're going to have those x and y's again. So essentially what we're going to be doing, and you can notice it most obviously in the midpoint formula, is where midpoint on a number line, you only have to take an average once. A midpoint on a coordinate plane, you have to do that twice. And most of these problems are just going to be plug and chug. I give you 2 points, you put them into the distance formula, it kicks out a distance. No big deal. However, there are going to be problems like those seen on this page that are a little bit trickier. So for example, this first one says find the value of C such that the distance between points with the given coordinates is 5 units. So again, as I always do with the word problems, I'm going to point out and I'm going to write down my important information. So it says distance between the points. Right away, I have distance. D is 5 units. I'm just going to write 5 there. And then I have 2 points. I have -2 comma C and 2 comma 1. And then I'm going to go up and find my distance formula, which in this case is right here. Now notice this says PQ. These are the general coordinates that I used in this formula. It doesn't really matter because everything on the actual problem is just going to be in terms of x's and y's anyway. So right away, I'm going to label these. I'm going to say that this is my coordinate 1, this is my coordinate 2, making this one x1, y1, x2, y2. From there, I'm going to plug it into the formula, except I need to figure out where this distance units comes in. Well, since I'm solving a formula for distance, even though this doesn't say distance, PQ is technically the distance between the 2 coordinates, and in this case, 5 is the distance between our 2 coordinates. So when I plug it into my formula, I get 5 equals the square root of x2 minus x1. It doesn't matter what order I go in. I could even do it the other way where I do x1, x2, as long as you're consistent between your x's and your y's. So x2, 2 minus -2 squared, that's this piece, plus y2 minus y1 squared. And now I just have to solve for my missing piece here. The first thing I'm going to do is simplify the inside in my head a little bit. However, if you're going through the steps, my suggestion for this would be to get rid of that square root first, and that's what I'm going to do here. So square root, both sides, I undo it by squaring both sides, and what I'm left with is going to be 2 plus 2, that's 4, so 4 squared is 16, plus whatever this is when I FOIL it out. And I'm going to tell you that it ends up being c squared minus 2c, and then when I add this 16 to the 1 that you get from foiling this, you get plus 17. So when we take the square root and we simplify everything on the inside, it becomes just this. All right, from there we're just solving the same way we normally would. Move the 25 over, we get c squared minus 2c minus 8. We factor it to figure out what c is going to be. 4 and 2, -4, +2, and c ends up equaling -2 or +4. And my point, in order to get a distance of 5, could be at -2 or 4. So I found the value of c. One other suggestion I want you to maybe take into consideration is, especially when we're looking at points like this where it's saying find the value of c, I always like to put my value of c back in just so I can see what those coordinates would look like. Now, looking at the coordinates doesn't tell me whether or not they're realistic or if they make sense, but it does show me if it's super, super off if I did something in my foiling. Maybe I got -2. If I get -2 here, and then I get -236, well, then I know that I maybe messed up just a basic algebra or arithmetic error in here, and I might want to check that second point again. But here, they're obviously pretty close, so I can reasonably say that those are correct. All right, the next one says that line segment AB is drawn on a coordinate plane. Point B, 2, 5, is an endpoint, while M, -1, 7, is the midpoint. Find the coordinates of the other endpoint A. Now this one's a little harder because while we could just plug and chug up here, this one actually has 2 pieces to it. So I'm going to actually write all of these down. Point B is at 2, 5. My midpoint is at -1, 7, and I don't know what this point is. I don't know x1, y1. And when I put everything into my formula, it's going to look a little weird. It's actually going to go -1, 7 is equal to the coordinate 2 plus x over 2, comma, 5 plus x over 2. Because I have plugged in the midpoint over here, just like my formula says, and then I plugged in x1 and y1, but I don't have x2 and y2. And you're thinking, well, how do I solve a coordinate equals a coordinate? I've never seen that. The only way to do it is actually to break this up. We know that our first coordinate here has to equal -1 because the x coordinate has to match up with the x coordinate. And the same thing goes for y. So I'm going to match this up and say that whatever this is equal to has to be 7. Once I know that, I can break it up into 2 separate problems. I can say that 2 plus x over 2 is equal to -1 and solve that appropriately, and then write 5 plus y over 2 equals 7 and solve that appropriately. So in this case, I'm going to multiply both sides by 2 to get rid of this fraction. So I get 2 plus x equals -2. Subtract the 2 over, and this one is going to be x equals -4. Same thing here, multiply both sides by 2, I get 14, minus the 5, I get y equals 9. Those are pretty easy to do, however, you have to understand the relationship between 2 coordinates, which isn't always really obvious. The other thing I want to do is draw a quick graph and make sure that my math makes sense visually. So if I put my first point on here, it's at 2, 5. My midpoint says it's at -1, 7. Just looking at the distance between these, I notice that I have to go back 3 and up 2. That is how I got from here to here. In order to get to A, if this is the midpoint, I should have to do the exact same thing. I should have to go back 3 again and up 2 so that my line is even for distance on both sides. If I do a little quick mental math, if this was -1 and I take away 3, that's going to be -4 in my x, which tells me my x coordinate was correct. And if I go up 2 from my 7 where I was at, that puts me at 9 on my y, meaning that my y coordinate was correct. So there's 2 different ways to do this. You can do it visually, but I also want you to be able to do it algebraically. All right, last one has 2 parts, so stay with me through all of it. It says circle O has a diameter AB. If A is at -6, 2, and I'm just going to write this down while I'm at it. And B is at -3, 4. Find the center of the circle and the length of its diameter. Well, if we're just looking at a basic circle and we know that AV is on either side, it makes sense that the center of the circle has to be the midpoint. So obviously right there, we're going to be using the midpoint formula. It also says find the length of its diameter. Well, it makes sense that if A and B are 2 points and we're trying to find the distance across, we're going to be using the distance formula. So this is actually a plug and chug problem. And if you want to pause the video here, see if you can plug things in where they belong, and then come back when you're done, I encourage you to do that. Otherwise, I'm going to jump right into the problem. So when we're computing midpoint, we are going to say x1 plus x2, -6 plus -3 over 2, comma, -2 plus 4 over 2. I'll work down here actually instead of working sideways. So -6 plus -3 is -9, divided by 2 is -4.5. -2 plus 4 is 2, 2 divided by 2 is 1. So our midpoint is at -4.5, 1. And then distance, same thing, excuse me. We're going to put in square root of x1 minus x2. In this case, it's a -3, so it becomes positive, plus y1 minus y2, or vice versa, whichever order is fine. Because we're squaring it, it doesn't matter. We're just taking the difference of the numbers. -6 plus 3 is -3, squared is 9, plus -6 squared is 36, so plus 36. This becomes square root of 45. I don't want to leave it like this just because I can simplify a square root. I'm going to. This is the same thing as 9 times 5. The square root of 9 is 3. So my distance from A to B, sometimes denoted A to B, is the same thing as 3 square root 5 units, which in this case doesn't give us units, so we're just going to label it like that. There we go. If you have any questions on the midpoint or distance formulas, just let me know.